Okay, in this video, we're going to use that factoring that we just went over to solve some polynomial equations. Here's your steps. Make sure that step number one, that everything is on one side, that it has to equal 0 or you can't use this. Step number two, we're factoring completely. And step number three, we're simply taking each factor, set it equal to 0, and solve. And that's it. For quadratic equations, solve by square roots, completing the square, or quadratic formula. Remember that. We have other methods that we can use for quadratic equations as well as factoring. We always simplify irrational and complex solutions. So like the square root of 20, we have to break that down into root 4 times root 5. The square root of negative 4, we would have to turn into the square root of 4 times square root of negative 1, which is 2i. So let's get to it. The first problem. Let me zoom in a little bit. X to the third plus x is equal to 0. Again, step number one, make sure that it equals 0. Everything's on one side. Step number two, you start factoring. Factor out the x, you're left with an x squared, and you're left with a plus 1. Try to factor it as far as possible, but once you hit quadratic, you can actually stop there. But try to factor it again if you can. Then you set each factor equal to 0. And you solve. This one's already solved. That one's done. The second one, since it is quadratic, we can solve this by taking the square root. We're going to take that plus 1 because we're missing a b term there, so it's going to be really easy. Move that plus 1 over by doing minus 1. We then get rid of a square by doing the plus and minus square root of negative 1. If you don't remember, by definition, the square root of negative 1 is I. So therefore, this has 3 roots, which is the most that it could have. And those 3 roots are 0, negative I, and positive I. Number 2, we're going to move everything to the same side. 4x to the third has no like terms. When you subtract 3x squared, that turns this into negative 10x squared. We are now going to factor. There is a 2 in common, and they both have 2 x's. That's the lowest power of x. 2x squared times a 2 and an x gives you this term, and a minus 5 gives you this term. Once you get to x squared, you can then set each factor equal to 0. So you have 2x squared equals 0, or 2x minus 5 is equal to 0. Divide by 2. Do the plus and minus square root, or you already know x is going to be 0 here. Now, I do want to point out, and I'm going to put this root has a multiplicity of 2. 0 is a root twice. So therefore, let's write that. The other one, move the 5 over. 2x is equal to 5. Divide by 2, and you get 5 halves. So you have 5 halves as a root, and 0 is a root twice, and that is the 3 roots that you are looking for. Number 3. X to the fourth minus 64 looks like difference of squares to me. 2 sets of parentheses. X squared, or factors into conjugates. X squared times itself gives you x to the fourth. 8 times itself gives you the 64. Check and see if you can factor again. You don't have to because they are both quadratic, but let's set each one equal to 0 because they won't factor again. This nearly would. This was nearly difference of squares. Now to solve it, we're going to move our 8 over. It gives you x squared is equal to negative 8. So therefore, x, to get rid of that squared, is plus and minus the square root of negative 8. Now we got to simplify that. Let's come over to the side. Square root of negative 8, we're going to split into root negative 1 and root 8. And then root 8, we're going to split into root 4 times root 2. So you have 2, an I, and a root 2. So therefore, x is equal to plus and minus 2i root 2, which are 2, not just 1, but 2 complex solutions. The next one, move the 8 over, gives you x squared is 8. So therefore, x is equal to plus and minus the square root of 8, which we can split the same way we did over there. X is equal to plus and minus 2 root 2. Number 4. Everything's on the same side. It's equal to 0, so let's start factoring. Factor out a 5 and factor out an x. That's your common factor. You're left with an x to the fourth and a minus 16, which is a difference of squares. Do not stop when it's x to the fourth and set it equal to 0 yet. You're not going to get all your roots. X to the fourth minus 16 is difference of squares, factors into conjugates. X squared times itself gives you x to the fourth, and 4 times itself gives you 16. Now you have 2 options. If you would like to, you could factor this again, and I'm going to, but you don't have to. Once you get to x squared, you can actually stop there and set it equal to 0. But I am going to factor it again. Bring down the 5x, bring down x squared plus 4, X squared minus 4 is difference of squares, which will again factor into conjugates. That's x times itself and 2 times itself. And you'll get the same answer, and hopefully you'll see that as we work through this. Either way, you would have got the same answer. Set each factor equal to 0. We are looking for up to 5 total roots, and we're going to have 5. Divide by 5 and you get x is 0, multiplicity of 1. Subtract 4 gives you x squared is negative 4. X is plus and minus the square root of negative 4, which you're going to split into root 4 times root negative 1. So that will be x equals plus and minus 2i. That's 2 more roots. Move the 2 over, it gives you x is negative 2. That's a total of 4 roots. Move the 2 over, gives you x is positive 2. That is your 5th root. Now just to show you, had you stopped here, moved the 4 over and done plus and minus the square root of 4, you would have got the exact same 2 roots as you did with factoring. Number 5, this is sum of cubes. I'm going to rewrite it as x to the third plus 5 to the third. Here's your formula. Identify your a and b values in your formula. Your a value is x, your b value is 5. So therefore, this is going to factor into, and we have to factor it, x plus 5, just plug it in for a and b, times x squared minus x times 5, which is 5x, plus 25. And now that's equal to 0, and now we're good. We have linear, which is fine, set it equal to 0. And since this is quadratic, it won't factor again. You can try it, but it will not. You can go ahead and set it equal to 0 as well. Our first root is negative 5. Our second root, now how are we going to solve this? You have options. Since factoring is not going to work, you can try it. Factoring is not going to work, you can either use completing the square or you can use your quadratic formula. I don't recommend completing the square because this is not an even number. The 1 is fine if you have a 1 out front, or if this is even, that's the best time to use completing the square. So I'm going to use my quadratic formula. Let me change colors here. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, again, I always like to do b squared minus 4ac first. Here's your b value. B squared would be 25 minus 4 times 1 times 25. That'll be 4 times 1 is 4 times 25 is 100. So 25 minus 100, which is a negative 75. And again, that's the stuff under your radical in your formula. Let's go ahead and clean that up before we plug it into the formula. It's just a whole lot easier. You're going to have the square root of negative 1 times the square root of 75, which I can split up again into root 25 times root 3. That's going to be 5i, and root 3. So that's going to be the stuff under the radical in your formula. So now let's plug in everything else. We'll come over here to do it. X is equal to negative b, so that's negative negative 5, plus and minus the square root stuff, all divided by 2a, which is 2. And you can split this if you'd like to and do 5 over 2 or 5 over 2, but since it's going to be decimals, I'd probably just leave it like this. So there's going to be your 3 roots. Again, this is plus and minus, so that's the reason that's 2 different roots. Now, since those are complex numbers, I just thought about this. Since these are complex numbers, because it has the I, if you'd like to divide it up into the 5 over 2, the real part, and the 5 root 3 over 2i, the imaginary part, you could write it like that as well. So either one of those ways of writing that would be fine. Number 6, everything gets moved to the same side, so you have 8x to the 5th. When you subtract 4x squared, you now have 1x squared. Factor out what's common. Your lowest power of x is 2. You're left with an 8x to the 3rd and a plus 1. And we're going to have to try to factor this again because it's a cube. We want to get it down to at least squared, and that's going to be sum of cubes. And I can actually just scroll over and use this exact same formula right here. Let's rewrite it, though. Change colors. 8x to the 3rd would be 2 times 2 times 2, and x times x times x. So that's 2x all raised to the 3rd plus 1 is the same thing as 1 to the 3rd. Plug in 2x for a and 1 for b gives you, and I can just write it right there below it now. Bring down the x squared, 2 sets of parentheses. A plus b would be a 2x plus 1. Your a squared would be 4x squared minus a times b would be 2x times 1. And then plus b squared would be a 1, and that's equal to 0. Let's set each factor equal to 0 since we're down to quadratics now. So you have x squared is 0, 2x plus 1 is 0, and 4x squared minus 2x plus 1 is 0. So here, take the square root and you get x is 0, and that's going to have a multiplicity of 2. Move the 1 over and divide by 2 gives you x is negative 1/2. So there's 2 answers here, 1 more answer here. That's a total of 3 answers. We're looking for 5 answers. This should give us our other one. And again, I'm going to use the quadratic formula here. And we can actually, again, still see the quadratic formula from our last problem over here. Let's start out with b squared minus 4ac, and I'm going to come up here to work that. B squared minus 4ac would equal b squared is 4 minus 4 times 1 would be a 16. That'd be negative 12, and again, that's under the radical. Let's simplify it into root negative 1 times root 12, which I can split into 4 times 3. So it'd be a 2 and an I and a root 3. That's the radical stuff. So my final answer here is going to be x equals negative b plus and minus the square root stuff over 2 times a is 8. And we can split that. That's going to be 2 over 8 plus and minus 2 root 3 over 8. And then most of the time your I is written, if it's a fraction, you can write your I out there next to it instead. So that's going to be 1/4 is the real part, plus and minus the 2 over 8 again reduces to 1 and a 4. So root 3 over 4i. So there's your other 2 answers, which again gives you the total of 5 different answers. Number 7, x to the third minus 216. That is difference of cubes. Here's your formula. Now let's identify what our a and b are. X to the third minus 216 can be rewritten as x to the third minus 216 is 6 to the third. So your a is x, your b is 6, so everywhere you have an a, put an x. And let's do it over here below our problem now. So that would be an a minus b times a squared plus a times b would be x times 6 plus 6 squared is 36, and that's equal to 0. And we now have it to where we can set each factor equal to 0. Either x minus 6 is 0, or x squared plus 6x plus 36 is equal to 0. Solve the first one gives you that x is equal to 6. That's one of my roots. I should have 2 more roots, and here they are. I'm going to use my quadratic formula again. Let's go ahead and copy that formula down. And let's do our discriminant first. B squared minus 4ac. B squared will be 36 minus 4 times 1 times 36 is 144. So that's going to be negative 108. Now, as I go through this, I noticed this was a 1x squared and an even in the middle, so this could have also been solved with completing the square as well. The negative 108, again, is the stuff under your radical. So we're going to split that into the square root of negative 1 times the square root of 36 times the square root of 3, which would be 6i root 3. Again, that's the stuff under your radical. So let's go ahead and your other 2 solutions. X equals negative b will be negative 6 plus and minus the radical stuff, 6i root 3 over 2a, which is 2. We can split that. That's going to be x equals negative 6 over 2, which would be a negative 3, plus and minus. This 6 over 2 is also going to reduce to 3i root 3. And again, if it's no fraction, I don't like to put this I at the end just because sometimes it'll get lost under that radical if we do. So we'll just leave it where it's at. So there's your other 2 answers. Number 8, everything gets moved to the same side. First, 16x to the third minus 54 is equal to 0. Right now, there's nothing that satisfies this except for factoring out a GCF. That GCF is going to be a 2. You're left with 8x to the third minus 27, which actually now matches your difference of cubes. So let's bring down our 2. Let's identify our a and b. 8x to the third I can rewrite as 8 is 2 to the third, and x to the third is x to the third. 27 is a 3 raised to the third. So here's my a, here's my b. Now let's plug that back into our formula. Everywhere I have an a, put a 2x. Here's your formula. Everywhere you have a b, put a 3. A squared would be 2x times 2x, which is 4x squared, plus AB will be plus 6x, and then plus b squared will be plus 9. There's the factored form. Now that we're down to that, we can set every factor equal to 0. Now, when you set 2 equal to 0, though, that can't be a true statement, so really you can just forget about the 2 and just set the rest of them equal to 0. 2x minus 3 is 0. 4x squared plus 6x plus 9 is 0. Now, I would not recommend completing the square here because of the 4 being out front. So your 2 roots are going to be, or your 3 roots, move the 3 over, divide by 2, will be 3 halves. Now let's again use quadratic formula. And I've still got it listed right here from my previous problem. Let's do b squared minus 4ac first. B squared minus 4ac. B squared will be 36 minus 4 times 9 is 144. So that gives you the same negative 108 you had on the last problem. And the square root of negative 108 simplified into 6I root 3 from the last one. So now let's go back and plug that back into our quadratic formula. So x is equal to negative b, which is negative 6, plus and minus the square root stuff, over 2 times a, which is 8. This can be split into 2 fractions so that you can see the real and imaginary part of your, these are complex solutions. Negative 6 over 8, plus and minus 6 root 3 over 8, and then you can put out the I next to it since it is a fraction. It does look okay. So your other 2 answers are negative 3/4 plus and minus, and you can also reduce this to 3/4 or 3 root 3 over 4I. Number 9. This is quadratic form, so this will be pretty easy to factor. 2 sets of parentheses, x squared times itself. What adds to give you 1, multiplies to give you negative 42 is a positive 7 and a negative 6. And again, right there, you can try to factor again, or you can just stop now and set them both equal to 0. We are looking for 4 roots. And again, it's going to be pretty easy to find all 4. Move the 7 over. Take the plus and minus square root of negative 7. Let's split it into plus and minus the square root of negative 1 times the square root of 7. The other one, move the 6 over. X squared is 6, so x would be plus and minus the square root of 6. Square root of 6 does not simplify, so you're done. And again, x to the 4th, if you'll think about why does it have 4 solutions? Even though it's 2 imaginary, it's going to come up. Now, sometimes it has 4 roots, and they're all real. However, this one had the 2 imaginary, so it's going to look more like this, where you had the 2 real roots, and then you had the other 2 roots were imaginary roots because they didn't cross the x-axis. Next up, let's move all of our terms to one side. Minus 9x to the 4th, we're going to now add it, so that'd be now 10x to the 4th. Plus 13 is minus 13, so you get negative 10 there. Let's factor out a GCF, which is 10, and you're left with x to the 4th minus 1. X to the 4th minus 1 is difference of squares. Bring down the 10. Difference of squares factors into conjugates. X squared times itself gives you x to the 4th. 1 times itself gives you 1. Now, a while ago, I went ahead and factored this again. But I'm going to go ahead on this one and just show you, once you hit x squared, you don't have to factor again. Do I have to set 10 equal to 0? No, because 10 can't equal 0, so you can just forget about that one. The other 2 factors, let's set equal to 0. I'm looking for 4 total roots here. Move the 1 over, gives you x squared is negative 1. So x is equal to plus and minus the square root of negative 1. Square root of negative 1 is I. Move the 1 over, gives you x squared is 1. So therefore, x will be plus and minus the square root of 1, which is 1. And that's the exact same answer you would have got if you would have factored that into x plus 1 and x minus 1. Okay, the next one, number 11. Common factor is an x. Pull it out first. You're left with x squared minus 8x and a plus 16. That is now a perfect square trinomial. It factors into, because of half of this is negative 4. Negative 4 times negative 4 is 16. So x times x is x squared. What adds, multiplies will be a negative 4 and a negative 4, or negative 4 times itself. So we can write that as x minus 4 to the 2nd instead of listing it twice. Set each factor equal to 0, x equals 0, and x minus 4 is equal to 0. And you might say, well, what happened to the 2? We'll show you in just a second. So one solution is 0, the other solution is 4. But because of the 2, that solution has a multiplicity of 2. Now, just a quick reminder, the graph looks like this because it's x to the third. It crosses at 0, and it touches at 4. It doesn't actually cross. Remember the tangent. Number 12, factor out your common factor. 2, 10, and 48 has a factor of 2. The lowest power of x is x squared. Factor that out. You're left with an x to the fourth, a negative 5x squared, and a negative 24. Factor it again. 2x squared, 2 sets of parentheses. X squared times itself gives you x to the fourth. Adds, multiplies, negative 8, positive 3. Once you get to x squared, you can now solve it from here on out. Set each factor equal to 0. And just solve. Divide by 2. And take the square root, and you get x equals 0. And again, that has a multiplicity of 2. Because the x squared, that's a root twice. Move the 8 over, gives you x squared is 8. So x will be plus and minus the square root of 8, which you can simplify into plus and minus the square root of 4 times the square root of 2. The square root of 4 is 2. And the last one, move the 3 over, gives you x squared is negative 3. So x is plus and minus the square root of negative 3, which is plus and minus the square root of negative 1 times the square root of 3. And the square root of negative 1 is I. So there is your, let's see, we're looking for 6 roots here. There were 2 here, and 2 here. Number 13. Move everything to the same side. 3x to the fourth minus 2x to the second minus 16 is 0. There is no GCF. It's 1 here, so nothing factors out. So we're going to have to use bottoms up if this is factorable. X to the fourth minus 2x squared minus, move the 3 to the end, 48. 2 sets of parentheses. X squared times x squared, but what adds and multiplies would be a negative 8 and a positive 6. You moved a 3, so now let's divide by the 3 that you slipped. 8 thirds will not divide, so therefore you're going to move the 3 back to the front. 6 thirds will divide, so you're going to turn that into a 2. Now that you have it factored out, we're going to set each factor equal to 0. 3x squared minus 8 is 0. X squared plus 2 is 0. In one step, I'm going to move the 8 and the 3 at the same time. Let's move the 8 over by adding 8, and then you're going to divide by 3, gives you 8 thirds. So therefore, x is equal to plus and minus the square root of 8 thirds. Now, I do want to remind you that you can split those. The square root of 8 thirds is the square root of 8 over the square root of 3. Now, why would I want to do that? I need to rationalize those. I need to get that radical off the bottom. The way that you do that is by multiplying top and bottom by root 3. And that's going to be root 24 over 3. A radical times itself gets rid of radicals. Now, the square root of 24 on top, we can clean that up now. That's going to be plus and minus the square root of 4 times the square root of 6 over 3, which is plus and minus 2 root 6 over 3. There's 2 of the answers. Then x squared plus 2, let's move the 2 over, and you get negative 2. So therefore, x is equal to plus and minus the square root of negative 2, which we're going to split into plus and minus the square root of negative 1 times the square root of 2, and that will not simplify any further. There's the 4 answers. Number 14, move everything to the same side. 5x to the fourth, no like terms. X squared, you're going to subtract an x squared. You now have 12 of them. Plus 1, you're going to subtract 1. You have now negative 9. There are no common factors, so let's move the 5 to the end. So you have x to the fourth plus 12x squared minus 45 is equal to 0. Let's factor it, 2 sets of parentheses. That's an x squared and an x squared, adds, multiplies. Let's see, that's a positive 15 and a negative 3. You slip the 5, so now let's divide by it. And you'll have now an x squared plus 3. And this will not divide or reduce, so move the 5 up front. It'll be 5x squared minus 3. Set each factor equal to 0. X squared plus 3 is equal to 0, or 5x squared minus 3 is equal to 0. Move the 3 over, gives you x squared is negative 3, so x is plus and minus the square root of negative 3. Split it into the square root of negative 1 times the square root of 3, which is I root 3. Move the 3 and the 5 over, gives you x squared is 3/5. So x is equal to plus and minus the square root of 3/5, which can be split. Let's rationalize that by multiplying top and bottom by root 5, and that's going to give you plus and minus the square root of 15 on top and 5 on bottom, and that's your other two answers. Number 15. Everything's moved to the same side. There's 4 terms. Anytime you have 4 terms, you try to factor by grouping. The first group, common factor is an x squared. Factor it out, you're left with an x and a plus 2. Second group, the common factor is a 5. Factor it out, you're left with an x and a plus 2. The two groups have an x plus 2 in common. Factor it out, and you're left with an x squared here, and you're left with a plus 5 here. Now that you've gotten it down to linear and quadratic, you can now set it equal to 0. So you have x plus 2 is 0, or x squared plus 5 is 0. So either x is negative 2, or move the 5 over, gives you x squared is negative 5. To get rid of a square, we're going to do plus and minus the square root of negative 5. And that would be x is equal to plus and minus the square root of negative 1, which we know is I, times the square root of 5, and that's it. And the next one. Again, same thing, 4 terms, group them. First group has the smallest power, x squared, in common. Factor it out, you're left with a 2x and a minus 3. Second group has a negative, and if this is a minus, always try to factor out a negative just to see, and you're going to be left with the same 2x minus 3. So it worked. Factor those, pull the 2x minus 3 out of each. You're left with an x squared in the first and a negative 16 in the second. Now this is not factored completely. This would factor again. However, since we're solving an equation, if you would like to, let's go ahead and stop, set them each equal to 0, because to me, it's easier to write it and solve it if you don't factor it. Move the 3 and the 2 over, gives you x is 3/2. That's your first answer. And the reason this, again, is easier to solve like it is I can just move the 16 over and do plus and minus the square root, which is just 4, and that's so much quicker than doing it the factoring way.